This is Miss Parody, and in this video I'm going to talk to you about direct variation. Let's look at an example first. Susan can jog at a steady rate of 10 meters per second. Describe the relationship between her distance traveled and the time that she runs. So, we're given that Susan runs at a rate of 10 meters per second. We know from studying rate of change that this 10 meters per second is a unit that is a change of distance over a change of time. So for every 1 second that Susan runs, she's going to cover 10 meters in distance. We say that this is direct variation because the distance varies directly with time. The distance is going to depend exactly on how many seconds that Susan runs. So part B of the question is asking us to complete a table of values showing the distance that she runs. We set up our table of values. Time, being our independent variable, is on the left-hand side, and distance, which depends on time, is on the right-hand side of our table of values. We list independent values of time from 0 to 5. I just chose those arbitrarily. You could go up much higher, but we obviously cannot have negative values of time. So let's look at the first value. If Susan jogs for 0 seconds, she's obviously going to travel 0 meters. No time means no distance. In the first second that Susan runs, she will have covered 10 meters because she's running at 10 meters per second. So as we go down the chart, add an additional second, so at 2 seconds she's traveled 20 meters, 3 seconds 30 meters, and 4 seconds 40 meters, 5 seconds 50 meters. So you'll notice that the distance that she has traveled is 10 times the number of seconds that she has traveled. So each time that our time intervals go up by 1, our distance intervals go up by 10. Part C says graph the relationship by plotting the points from the table of values. Now that we've created this table of values, going back to last night's video, we know that we can plot these points very easily. Looking at the graph that has been set up here, we have our independent variable time on the horizontal axis and our dependent variable distance on the vertical axis. We've labeled the situation with a title, and we're ready to plot. So the first point is 0, 0. So when time equals 0, distance equals 0. You can plot that right there at 0, 0. The next coordinate pair given to us by our table of values is 1, 10. So when time equals 1, distance equals 10. Third is 2 and 20. So we go over 2 for time, up to 20, and so on and so forth. Every time we go over 1 second, we're going to go up 10 meters. Over 1 second, up 10 meters. So this line clearly has a slope of 10, which was exactly what the question had given us, a rate of change of 10 meters per second. If we were to continue this graph on infinitely, for every additional second she would run, the distance would go up by 10. So we can put in a line through this with an arrow showing that it goes on forever. Part D, determine an equation that represents D in terms of t. We've already spoken about this a bit in words, and let's just go back to the graph. We notice that distance is a multiple of time. More importantly, distance is equal to 10 times time in this case. So the distance is equal to the slope, 10, times the unit of time that Susan has run. So d is our dependent variable, distance, because distance depends on time. Whenever we're creating an equation of direct variation, the dependent variable is always the variable to the left. It is always the variable that depends on the independent variable. 10 is our slope, also known as rate of change, and now we're throwing in another term. It also represents what it can be called as the constant of variation. And t, of course, is the independent variable, time, and this is the variable by which the distance varies. So equations for direct variation always are in the form dependent variable is equal to the slope or constant of variation times the independent variable. Now that we have the equation, it's important to note that we always include the equation in the graph. So if we have created a graph and an equation, it is customary to write the equation next to the line to give it a name. So in summary, direct variation is a relationship between two variables in which one variable is a constant multiple of the other. So using words, we can explain direct variation by saying the dependent variable depends directly on the independent variable. Graphically, we know that direct variation is a straight line that passes through the origin. So it's very important to note that with direct variation, the line starts right at the point 0, 0. It increases up or decreases, but most importantly, it starts right at the origin, and our dependent variable is always some constant multiple or slope of our independent variable. Using an equation or algebraically, the formula or equation that we use for direct variation is y is equal to mx. So in other words, our dependent variable is a constant multiple of our independent variable.